On the other part to this section, is simplifying these rational expressions or right in lowest terms, they may phrase it that way. Yeah, we're talking fractions, so sometimes fractions can be reduced. We're talking about reducing fractions. Now, first of all, let's talk about in canceling in fractions. Say we've got x plus 5, x plus 3 times x plus 3 on top, and then x plus 5 times x plus 4 on the bottom. And I want to simplify that as much as I can. Well, obviously there I have some canceling I can do. I've got a common factor on top and bottom, so yes, obviously the x plus 5s do cancel. Out, and they're 1. We're canceling to 1, but that essentially wipes them out from the fraction there. And we wind up with x plus 3 over x plus 4. Now, can I do anything further? No, I can't. I can't cancel any further. Yeah, the thing I like to point out is if you're going to cancel a binomial or something higher, like a trinomial, it has to be an exact match. To cancel a binomial, you have to have an exact match. An exact match. Okay. In other words, I can't cancel these x's out because it's x plus 3, you see. That's the factor. So if I cancel the x, I have to be able to cancel the plus 3. Same thing, if I cancel the x, I have to cancel it with the plus 4. Because those aren't exact matches, I can't do anything with them. That's it. That's as much as I can do. There's no further canceling to be done. Okay? Same thing would go, what if I had x minus 5 over x plus 5? Think I can cancel those out? No. Can't cancel those out either because, again, not exactly matching. Yeah, if it's one thing different about it, you just can't cancel it in the binomials. Okay? All right. So knowing that then, let's talk about some others. X squared plus 3x plus 2 over x squared plus 5x plus 4 I'm talking simplifying these. X squared plus 3x plus 2, x squared plus 5. Yeah, again, I can't cancel those x squareds and so forth. No, what you first want to do here is just say factor first. Okay. Write that note, underline it, star it, whatever. Yeah, if you can factor numerator or denominator, you're going to want to do that first. Okay, so on these, just like we were doing on the factor chapter, yeah, you see a trinomial, should want to factor it if you can. Factor, factor, factor. Okay. All right, so if I factor that top, x squared plus 3x plus 2, there is some canceling, possibly that we can do. Now the top, x squared, so it's x and x, 2 with 3 in the middle, that's 2 and 1, isn't it? Then on the bottom, x squared plus 5x plus 4, it's x and x. 4, 5 in the middle, 4 and 1, plus 4 and plus 1. And so, yeah, there you see, I do have an x plus 1 I can cancel. But what about the x plus 2 and the x plus 4? No, not an exact match. That's as far as it goes. Okay? All right. Now, having said all that, let's talk about this one. 12x cubed times x minus 3 over 10x squared times x minus 3. Okay. Obviously, yes, there. The x minus 3's cancel. Now let's talk then about what's left. What's left is 12x cubed over 10x squared. Anything happening there? Yeah, these these are basically I can factor those separately, however you need to think of it, but I can reduce, that's just 12/10, just like a regular fraction now. I'm not talking binomial. I'm just talking regular fraction now, so I can cancel, like a regular fraction there by 2. And then what about this? Well, I have the same base on those. I mean, they essentially have the same factors, don't they? What do I do, though, since they're divided? Subtract the exponents, yeah. So won't I wind up there with 6x to the first, or 6x over 5? Yeah, so if you have, if you have these monomials in front there, you can reduce those just like a regular fraction. Okay? All right, what about a couple more here? What about 3x over 6x cubed minus 18x squared. 3x over 6x cubed minus 18x squared. Well, the deal on this middle one here was it was already factored out for us. But again, anytime you're able to factor numerator, denominator, factor anything you can. Word of the day there, okay? I can factor that denominator, can't I? To simplify it? Yes, I can. All right, so I factor my denominator. What have I got? Common factor, 6x squared. 6x squared is a common factor of those two. What does that leave me? X, parentheses x, minus 3. Okay. All right, well, based on what we just talked about, these monomials, if you will, can I do a little bit of simplifying there? Yes, I can. The 3 and the 6 does reduce by 3s. 1 on top, 2 on the bottom. What about the x's? Well, that's x to the first, x squared on the bottom. It's going to leave me an x to the first in the bottom, isn't it? And so that clears out all the canceling. Now, I canceled everything on the top, but does that get rid of it? No. There's a 1 up on top, isn't there? Yeah, when I'm canceling these, like I'm canceling the x minus 3's out, or I cancel the factor of 3 out of 3, that leaves me 1. So there's always a 1, if I need it, left over there. Most of the time I don't have to write it because there's other stuff with it. But if I cancel everything out on the top, yeah, there's a 1 still left on the top. Now on the bottom, what do I have? 2x and x minus 3. Right? Okay. All right. Let's see. How about a squared plus 8a plus 7 divide that by, well, let's make it minus a minus 7. All right, so simplify that. What are you thinking? First of all, first step, factor it. Yeah. If you can factor it, that's what you want to do. Factor first. Trinomial factors. I do believe A and A for A squared, 7 and 1 would work because it's 8 in the middle. Add those, you got 8. So that's the way that one factors. Now on the bottom, what if I have that, a minus a and a minus 7? Well, I can factor that. How can I factor that? Pull out minus 1, yeah. And I'd want to do that because if I pull out a minus 1, that leaves me a. Minus 1 off of that, divide it by minus 1 gives me a positive 7. I'd want to do that because, yeah, that'll match it up nicely with the a plus 7 there on the top. And so that leaves me a plus 1 divided by negative 1. Which is one of the reasons I brought this up. That can be written a lot of simpler ways. You know, again, this negative 1 divides both of these, doesn't it? So one thing I'd say is a divided by negative 1 is negative a. 1 divided by negative 1 is negative 1. So I could do that. Divide them separately by negative 1, and that gets rid of the denominator. And then the other thing is, just like we did with the minus a minus 7, I could say, well, factor off a minus 1 there, and we get that. Either one is usually acceptable.
So we can leave it a plus 1 over negative 1?
Leave it a plus 1 over negative 1? Probably advise you to not, but if you did, you might be okay. But I would go ahead and, you know, usually having a fraction is less desirable than not having one. So that's the only deal. So now the other thing to mention is this. Again, simplifying here. We said earlier, you know, this is x minus 3 over 3 minus x. Earlier we said x minus 3 over x plus 3, you just can't simplify that. This is a little different, though. Do you see maybe a little difference here? This is x minus 3, this is x plus 3. This is x minus 3, and then this is just the reverse of it, 3 minus x. And it turns out in those scenarios you can reduce. Here's how. If I think about here, kind of what we did on the top one there, if I take this bottom and factor off a negative 1, just like we did with the bottom up there, factor off that minus 1, what that'll do here is is change that to minus 3 and that to plus x, right? Because it's divided by negative 1 gives me negative 3, divided by 1 gives me positive x. Well, if you look at this in the parentheses, minus 3 plus x, isn't that x minus 3? I just flip those around, positive x and minus 3, I could write it that way. Turns out the minus 3, x minus 3's cancel. Now that leaves me 1 over negative 1, and 1 divided by negative 1 is certainly negative 1. So yeah, this, in those cases, when you have a scenario like that, it does simplify, and it simplifies way on down to be minus 1, compared to that which that doesn't simplify. If you get something like that. Now, this one, y squared minus 4 over 2 minus y. You see on this one, the top does, it's a difference of squares there. Right? So I can do y minus 2, y plus 2 for the top. With me on that? Okay. Then on the bottom, because this is 2 minus y, and I've got a y minus 2 up there, shouldn't I do the same thing with it that I did with the previous one? Yeah, let's pull out a minus 1, and that'll make it minus 2 plus y. And if you have to, go ahead and rewrite it and flip that around. On the bottom, minus 2 plus y is y minus 2. The y minus 2's do cancel, so I'll wind up with, well, something similar we just talked about. We have y plus 2 over minus 1, which probably simpler. Divide those both by minus 1 or factor off the minus 1. Either one of those would probably work. See that? Okay.